Hi everybody, welcome to another video in Business Calculus, section 10.1, the derivative. We study about limits, and finally we get into the calculus part, derivative. So before we get there, let's just go with something basic, like rate of change. And even more fundamental than this is the slope of the tangent line. I'm sure you see this before. Let's say we have the function, or just say that we have a line, for example. And we have x equal to a going to x equal to b. And this is the values of the function when x equal to a, the values of the function when x equal to b. So in that case, the slope of the tangent line, the slope of this line is just equal to the difference in the y over the difference in x. In grade school, there's the formula, a slope equal to y2 minus y1, x2 minus x1. All of that are the same. Essentially, it is the average rate of change. So now the problem is then not only just for a line, it could be a curve. For example, we have a curve y equal f of x like this. Then the formula, this formula is the average rate of change. Right. So instead of writing like this, we can always use f of b minus f of a over b minus a. That works out perfectly. Now instead of that, we say, how about we just say we go from a and b here. Let that equal to a plus h. So where h is the distance from a to b. So go from a to a point h away from a. And then we have this pretty much the same formula. But at the bottom, a plus h minus h, a and a cancel out, we just have h. Bottom line is the average rate of change is the slope of a line. And this line is called the secant line. Slope of secant line. So we can just use that formula. If you do not want to use this formula, use that. Either way. Right, now let's look at the first example. The revenue from the sale of X plastic planter boxes is given by this. Find the average rate of change from production from 100 to 400. By the way, I prefer to just use that one if it is the average rate of change. So f of b minus f of a over b minus a. Right. Now, we go from 100 to 400. So one of them is a, the other one is b. So let's say a is 100 and b is 400. So we will have from 400 minus 100 over 400 minus 100. Right? So the y values at 400 minus the y values at 100 over 400 minus the 100. So the change in y over the change in x. The change in the values of the function over the change in x. Right? Now, we just simply put 400 into this. 400 put into x. and then 20 times 100 minus 0.02. I hate it when I was space. I'm just going to write here. Put 400 into x. And then subtract. Now we put 100 in for x. Over 400 minus 100. Right, so the nice thing about this is we can call the point 100 to be b and 400 to be a. It doesn't matter. A and b, a could be bigger than b, b could be bigger than a. It doesn't matter, but have to be consistent. If we have f of b minus f of a, it have to be b minus 8. Have to be the same point. Right. Now we have the calculator. The best way to do this, just use the calculator here. What I use is, let's say we have 400. I will store it into x. And then we just said we have 20x minus 0.02 x squared. And that is 4800. And now we let 100 store into x. So now x is equal to 100. If you can just hit the up arrow, copy and paste, that will do it. If not, just hit second enter until you see the function, the line that you want. Hit enter. That's 1800. 400 minus 100 is 300. So 4800 minus 1800, that's 3000 over 300. The answer is 10. So every change from production is 10. What does that mean? That means the revenue is increased by $10 when we produce one more. So I should say from 100 to 400 on average, revenue is $10 each. So the unit is dollars per unit. So that average rate of change. Yeah. Right, next. A small steel ball dropped from a tower will fall a distance y in x seconds given by this. Find the average velocity from 2 to 3. So average velocity or velocity on we can just say speed is distance over time. In this case, we just find average velocity. So the distance over the over time, pretty much. So the function we have x equal to 2 to x equal to 3. So again, we can call one of them is a, the other one is b. I just use 3, and then 2, and then 3, and then 2. This have to be consistent, right? Now put 3 in for x. And then minus 16 times 2 square. Then 3 minus 2 will be just 1, so this is 1, and so we have 16 3 square, so 16 times 9, and then 16 times 4. Right. 16 times 9 is 144, minus 16 times 4 is 64, so 16 times 5, that should be 80, so right, so 80. So from 2 seconds to 3 seconds, the average speed is 80. The unit should be feet per second. As the previous one, the unit would be dollars per unit. Right. So, and like I said, you can use that formula as well. But just go, if there's average rate of change, average velocity, just go y times a, y times b, and just find the slope. And it'll be just that. And then there's the reason we write in this formula. So now we go to instantaneous rate of change. So first, the average rate of change when we see it is from x equal to a to another point. So there are 2 points here. And if there's 2 points, the line will cut the curve. So that's why they call it secant line. Now, here we have only exactly at 1 point. So instantaneously, it only happened at that point. So we have the average rate of change is this. And if we let h, the distance between the points, go to 0, essentially we just have a point, right? Essentially we have identical point. If we let this h distance between the 2 points get smaller and smaller, essentially the 2 points will be identical, and that's what we have here. If we fix the point A, and then we take the other point A plus h, and originally we have the line that cut the curve. Now we take that point and we move closer and closer to A, move closer and closer to A, so we just have the line just go like this, and essentially it just become 1 point, and this is just one line tangent to the curve. So the second line becomes the tangent line when we fix 1 point and move the other point close to it. If we take the limit, that becomes just an instantaneous rate of change, which just happened at 1 point. Right? So, and again, we talk about if we have 2 points, we have the secant line, and if we have just 1 point, that is the tangent line. The tangent line is the line that touch the curve, and the secant line tangent mean to touch, and the secant mean it cut. It cut will be at 2 points. When it touch will be at 1 point. Right. And finally, I just want to emphasize that again. We fix 1 point, and then we let the other point closer and closer to it. And essentially, the secant line become the tangent line. The average rate of change become the instantaneous rate of change. So all we need to do is just throw in the limit into it, and let h go to 0, and that is called the instantaneous rate of change, the slope of the tangent line, and later on that is also the derivative. Right. Let's look at this example. Find the instantaneous rate of change for this function at x equal to 2. Right. So just the rate of change, but with the limit. over h. So that is the instantaneous rate of change. Now, in this particular case, a is equal to 2, so we're going to have 2. I'm just going to put 2 in it. Two in for 8 and then over h. Right. Now, this is a function. First we put 2 plus h into x, and then we put 2 into x. Right. S will be, and while you do that, don't forget there's the limit of h that goes to 0. Right, first I put 2 plus h into every x of the problem. So minus 2 plus h square plus 5 times 2 plus h. And then minus, where we put 2 into x. And all of that over h. Right? So I'll start with the formula. Average rate of change, instantaneous rate of change when we let h go to 0. And then the problem say that is at 2, so we're going to put 2 in for a. And then in that formula, substitute each one in the parentheses in x, both of them, both of the x's. Right, now just simplify. Y is 2 plus h. Square meaning multiply by itself. I'm just going to multiply this. That gives us 10 and 5h. Multiply now. Now in the parentheses or the bracket, 2 squares 4 plus 10. Right. That. Don't forget there's still limit over h. Right. Now multiply them out. Ignore the minus. 2 times 2. 4. 2 times 8 is 2h. Plus another 2h. So that is, just multiply it out. 2 times 2, 2 times 8, h times 2, h times h, plus 10, plus 5h, minus, that would be 10 minus 4 is 6. This is h squared, sorry, h times h. Right. Now, negative 4. This negative distributed everything. Negative 4. 2h and 2h, that 4h. And the negative. And the negative h squared. And 10 minus 6 is 4, so plus 5h. Plus 4 over h. By combine like terms, minus 4 and 4 cancel out. 5h And for h, we just have all, I just want to write negative h squared plus h over h. Now the term on top have h. I will factor it out. That gives us negative h plus 1 over h. Right, and then cancel out h. Now when h equal to 0, I substitute in 0, and that is equal to 1. So the answer is 1. Right, so we start with that formula and then substitute into every x and subtract. We substitute the second values into x and simplify. At the bottom, we should cancel out the h at the bottom. And so that is the instantaneous rate of change of that function at x equal to 2. Right, now we go to the derivative. For the function y equal to f of x, we define the derivative of f at upon x denote f prime of x is that. So we say, what is the difference of this formula and that formula? Well, the difference is in derivative. We define that at every x. So derivative is in turn is a function because it has x in it. So when we do this kind of things, like exactly like this, except if we leave x in it, the answer will have x in it. So the notation is just the apostrophe. And if the derivative exists, then it is said to be differentiable over the interval. Right? So, to recap, that formula is pretty much the instantaneous rate of change, and the instantaneous rate of change is also the slope of a graph, the slope of the tangent line to the graph, and instantaneous rate of change. So all of that kind of similar. Instantaneous rate of change, slope of the tangent line, and the derivative. The only difference is that the derivative is defined at x instead of upon. Right, and if the derivative exists, it is called differentiable. Right. So before we go finding the derivative, I just look at the case where the derivative does not exist. So the way we define derivative is like that. Of course, if it is at a, we can put x in it too. It doesn't matter. But this is the derivative at x equal to a. Perfectly fine there. So loosely speaking, it is slope. So what happened if the limit does not exist? All right, once. If it's not continuous, it does not exist, because in order, when we do this, the slope of the tangent line, we take the point getting closer and closer to it, and it has to be continuous. Otherwise, it is undefined. And if it's undefined at one of those points, the limit does not exist. So there's no derivative. So the limit have to be exist. So all of those have to be defined. So they have to be continuous. Right. So that's why continuous is important, otherwise one of this may not be defined. Right, smooth. So what is smooth, by the way? Smooth is this, as opposed to that is not smooth. So why do we need the function to be smooth? Well, remember, slope of the tangent line, instantaneous rate of change, derivative, all of that, the same thing. But at this point, just one point on the left, the slope is this line, so it go that way, and the slope of the other line go the other way. So that's why the tangent line on both sides are not the same. So the limit does not exist. It's just like one left-sided limit and right-sided limit are not the same. So in this case, the tangent line on one side do not agree with the tangent line on the other side. So that's why if it's not smooth, the tangent line are not aligned. So the derivative does not exist. And finally, if it has the vertical tangent line, the slope is undefined. So we need the slope to be defined, therefore it cannot be vertical. So the little note here, vertical line has undefined slope. So because the slope is undefined, the derivative is undefined, therefore we cannot have the vertical line. So if it is not, okay, if it's not continuous, this one of the function is not defined, and so that does not exist. It have to be, if it's not smooth, then we might have the tangent line do not agree on either side, and so that is not differentiable. And finally, if we have the vertical tangent line, then the derivative does not exist because the slope does not exist. Right. So we have the definition of the derivative. Now just find the derivative of this function using the definition. Right. I will put the definition here. F prime of x limit as h go to 0, f of x plus h minus f of x over h. Right, so that is the definition of derivative. Later on, there's a lot of different rules we can use to find derivative, but for now, derivative is all we got. So let's just start with the derivative, the formula. Limit as h go to 0, f of x plus h minus f of x over h. Right. So the function is 2x minus x squared, so there's an x here and x there. So if we substitute x plus h here, we have to substitute in every x. So x plus h substitute into this x, and x plus h substitute into this x. We have 2. Instead of x, it's going to be x plus h. And instead of this x, it's going to be x plus h. And then subtract f of x, which is the original function. All of that over h. And of course, the most important, don't forget there's still the limit, right? Right, multiply this out, 2x plus 2h, x plus h and x plus h. Because square meaning multiply by itself. Minus 2x minus a negative, that plus x squared. Right. I can simplify the 2x here already, but just keep that for now. Right, 2x plus 2h minus, now multiply this out, x times x, x squared, x times h, plus h of x, plus h squared, minus 2x, plus x squared. Right, 2x, 2h, minus x squared, one h of x, 2h of x, minus 2, because there's a minus here, 2hx, and minus h squared, minus 2x, plus x squared, over h. We can cancel out 2x here and the negative 2x here, the x squared and the x squared cancel out as well. So we left with 2h minus 2h x and minus h squared over h. Notice that all of them have an h on the top, so I can factor it out. So we have 2 minus 2x because we factor out the h, and factor out 1h, the h squared, factor out 1h over h, and then we can simplify this h with this h. So that gives us a limit h go to 0 of 2 minus 2x minus h. Now h equal to 0, so that's simple. I just substitute 0 into h. So we end up with 2 minus 2x minus 0, or just 2 minus 2x. So that is the derivative of the function 2 minus 2x. In the next section, there's a rule, so we can do that without using the derivative, the definition of derivative. But here we use the definition. Right. In the definition of derivative, if we do that, there's the step that we need to will be repeat over and over again. So the first step is there's a h at the bottom, so somehow we have to cancel that. In order to cancel that, we have to be able to factor out the h. In order to factor out the h, everything without an h we got cancelled out. So the first thing, everything that does not have an h in it cancel out. If we do it correctly, that step should be there. The second step is cancel out the h at the bottom. So those are the two steps. The first one is everything without an h got cancelled. The second one, cancel the h at the bottom. So I will write these two notes. So number 1, there is a step where we cancel everything that doesn't have an h. And the second step is cancel the h at the bottom. If we do correctly, we should see these two steps. Right. Now let's use that definition, this definition again, for different type of function. definition of derivative is still just limit as h go to 0 of f of x plus h minus f of x over h. Right. So we have at x plus h instead of x. So we have f of x plus h instead of x. So pretty much we substitute x plus h into x. Substitute x plus h into x. And the f of x is just the original function of that over h. Right. Right. F of x. Now f of x plus h. Just replace the x by x plus h. So we'll replace that into this x. Right. Now how do we find this limit? Of course, the first thing is we're going to put in 0, but there's still x in it. So what we do is, remember when we find a limit that involves square root, we try to get rid of that. Well, same thing. We try to get rid of the square root. But to get rid of the square root, the best way is to multiply by the conjugate. So we have square root of x plus h minus square root of x over h. We try to get rid of this square root. So the conjugate multiplied by the conjugate of it. Right, so that multiplied by the conjugate. Remember, we did say multiply by the conjugate. We have to multiply top and bottom because we cannot just multiply to the top. But we did say multiply by the conjugate. So if they are not conjugate, don't multiply it. Don't multiply the h here because we need the step where we cancel the h at the bottom. So we want the h to stay there with this. So just keep it like this at the bottom. Don't do anything at the bottom. Now just multiply on the top. And so just distribute the first outer and then inner last. Right. Square root times square root, so that square of x plus h and then plus square root of x plus h and then minus square root of x plus h and then minus square root of x square all over h times square root of x plus h plus square root of x. Right, like I said, only multiply the conjugates. If they are not, do not multiply them. Right. Actually, we don't need that much. Square root, square cancel out, so we just have x plus h. The middle terms cancel out, so that is where we multiply by the conjugate. The middle terms always cancel out, and then the square root cancel out, so we just have this. So on the top we just have x plus h minus x, and the bottom is h square root of x plus h plus square root of x. X and x minus x cancel out, we just have an h. And then cancel out the h. Have 1 over square root of x plus h plus square root of x. Right, let's stop and then see what we compare to what we did earlier. Remember there's 2 steps, right? Cancel everything without an h, and then cancel h at the bottom. So did we have that? Here we cancel everything without an h, and then we cancel the h at the bottom. So like I said, most of the problem, if we done it correctly, like I said, most of them, not all, we should have those 2 steps. Now, just need to put the 0 into h. And that's what we have. So just have 1 square root of x plus square root of x, and that give us 2 square root of x. Right. So that is the derivative of the function square root of x is 1 over 2 square root of x. Right. So once again, in the next section there is a formula to find derivative directly without using the definition. But for now, that's what we do. Right. Now we have the function of 2 over x. The derivative, we still start with the definition. Right. Now, the function is 2 over x. F of x is 2 over x. Now, if we have x plus h instead of x, I just simply substitute x plus h into x, right? Once again, remember we have the problem with instead of x, let's say if we may have the box, and now we have the box. If we have the smiley face, now we have x plus h, then it will be x plus h. So we just replace exactly what we have in the parentheses and replace the same thing into x, every x of the problem. So we just have 2 of x plus h minus the original function over h. Right, how do we simplify this? Well, one way to do that is to find the common denominator and then add them and then divide fraction. I will do that differently, slightly differently. Right. Now, what I see here is I don't want the x plus a at the bottom here. I don't want the x there. So if we want to get rid of something at the bottom, if we can multiply on the top, that will cancel it. So I will multiply x plus h on the top. When we multiply it out, that will cancel. I'll need to cancel this x as well. So multiply like that. Now, we cannot just multiply x plus h times x on the top like that. We have to multiply that at the bottom as well. right? Whatever we do on the top have to be the same thing at the bottom, right? Now multiply it out. Right, we have 2 x plus h, and then multiply x and x plus h. Distribute to everything actually. 2 over x, then we have x plus h, and at the bottom we have h x plus h. Right. Once again, we need to cancel out the h at the bottom, so do not multiply it out. Just simplify the top. We'll take care by itself. Right. Now we see there's x plus h and the x plus h here cancel out. X and the x cancel out. So when we simplify and clear things out, we have 2x minus 2 x plus h over h x plus h. And then multiply it out. 2x minus 2x minus 2h. At the bottom we have h x plus h. Once again, we need to cancel the h at the bottom, so we don't multiply it out. Right. Now the step, remember the step that we said cancel everything out, everything without an h. This one have no h, cancel with that. So that works out perfectly. That's what we expect. On the top we just have negative 2h. The bottom is h x plus h. Cancel out an h. We have negative 2 x plus h. Now 0, h go to 0, so we just substitute 0 in for h. Zero into h. So that's just x times x, so we have negative 2 over x squared. So that is the derivative of 2 over x using the definition. Like I said, if we do it correctly, usually we'll cancel everything without an h, and then later on we cancel the h at the bottom. Right, so that is the derivative. And once again, derivative is the slope of the tangent line, instantaneous rate of change, those related together. Now, the slope of the tangent line. What if we want the whole equation of a tangent line? Well, the whole equation of a tangent line is given by this. And in case you wonder where's that formula, coming from? Just going to say like this, right? So if we have the slope of the tangent line is equal to this. Over h. or we could say it a plus h minus 8, or just slope in general. Right. Now, instead of a plus h, let's replace that by x. And this by x. And the slope of the tangent line is the derivative. Now we just cross multiply it. We have f of x minus f of a equal to the derivative times x minus 8. Now, f of x we can replace by y. So we have y minus f of a is equal to that, and that is exactly what we have there. Right, so the equation of tangent line is given by this. Now find the equation of tangent line of that function given by at this point. Right, so first we're going to need to find the derivative, evaluate at the point, and then we just substitute in that formula. Right, just find the derivative, which is the slope first. Right, once again we just have the derivative. The definition of the derivative do not have any rule yet. Right, f of x plus h, once again substitute x plus h into this x, it is x. So we substitute x plus h into this x and this x, and then we subtract f of x, which is the original function. All of that over h. Right, just simplifying. Two times x plus h square will be multiplied by itself. And subtract that. So minus 2x squared minus plus minus over h. Sorry. Right, multiply it out. X times x, x times h, another hx, and then h squared. There's still 2 in front though. Then plus 1 minus 2x squared minus 1. Right. So that 2x squared hx and hx, that 2 of them times 2 will be 4, right? 2hx times 2, that will be 4hx, and then 2h squared plus 1 minus 2x squared minus 1 over h. 2x squared, because that does not have an h, that should cancel with something, just like the 1. So that's all we have. Both of them have h, so factor out the h. So we have 4x plus 2h over h. Cancel out the h and the h. We have 4x plus 2h. Now h go to 0, h go to 0, so just substitute into it. So I have 4x. So that is the derivative, right? Right. Now we have the derivative, we have the function. Now let's evaluate this the equation of tangent line that x equal to -2. The values of the function. This is the original function, not derivative. I put -2 into the original function. 2 times 4 plus 1. That 2 -2 squared is 4 times 2 is 8 plus 1 is 9. And derivative is 4x. So I'm just going to substitute -2 into x. That gives us -8. Right. So the values of the function is 9. The derivative is -8. Now let's substitute into the formula. Y minus f of a equal to derivative at a x minus a. Right. So we do have this. The values of the function equal to 9, and the values of the derivative is equal to -8. X and a is -2. So that gives us y minus 9 equal to -8 x plus 2. Right, so that is the equation of the tangent line. If you want to simplify that, that's perfectly fine. Just multiply it out. Minus ax minus 16. And then plus 9 on both sides. We have y equal to -ax plus 9, which is -7. So minus ax minus 7, sorry. Yeah. Plus 9 on both sides. We have minus ax minus 7. Right. Now let's graph them and see what we have. We have 2x squared plus 1, and then we have the line -ax plus minus 7. Right, let's take a look. This is 2x squared plus 1, and there is the tangent line to the function. If we zoom out, maybe we see a better picture. So that is that, and then there's a tangent line to it. Right. And with that, I stop section 9.4 here. As always, thank you for watching, and see you in another video in business calculus.